All right, well, let's finish these up then. Take a look at number 5. Read it carefully and thoroughly. You might want to have your flow chart sitting next to you for now until it's committed to memory. And by might, I mean definitely for now, right? Okay, read it over, think about it. So what I would do is as you read it, check each one of these 3 that applies, and then you can pick down here, okay? So we want to know what would make a parallelogram always be a rhombus. What do we think? If we had a parallelogram whose diagonals perpendicular bisectors of each other, would that always be a rhombus? Did you look at rhombus properties? Oh. So tell me what you think. Which of those 3, if any, or 2, or all of them, would make that parallelogram a rhombus? 1, 3, and 2. Okay. So let's get back to that. Diagonals being perpendicular bisectors of each other. Well, because of the parallelogram, they're definitely bisectors already, right? But this is perpendicular bisectors. What's that? Right. But will that make that parallelogram a rhombus? If the diagonals. Yeah, because that's a rhombus property, right? Okay. So definitely 1. How about 2? Diagonals bisect the angles from which they are drawn. In other words, opposite angles bisect. Look at your rhombus properties. Is that one of them? No? Look again. In a rhombus. Might be worded slightly differently. What's it say? Bisect at opposite angles. Same thing as from where they came from, right? That makes sense? So that would make it a rhombus. What about 3? Diagonals form 4 congruent isosceles right triangles. Well, let's draw a rhombus, right? And we have, this is perpendicular, right? So we know it just by thinking about it. We got 4 right triangles, don't we? The only question now is, are they isosceles right triangles in there? Are they? You know what isosceles means, right? 2 congruent sides? Well,
Yes.
why? Okay, because they are, because why?
Diagonals bisect each other.
Because now go back up and look at parallelogram. What about the diagonals, guys? They bisect each other, right? So that would mean that they are right triangles, aren't they? Isosceles right triangles? Yes? Okay. Right, wouldn't these be congruent? Maybe. You think? Wouldn't they be 4 isosceles right? We got 4 right triangles. What do you think about this one for a minute? Will those 2 congruent marks there be valid? No? Why not?
Because from one side to the other, not both sides of the triangle.
Okay. So what you're saying is a rhombus doesn't necessarily have congruent diagonals, right? See, this is what I want you to think about. This is a little bit tricky. So if it's a rhombus, they're not necessarily congruent diagonals. What has congruent diagonals? Okay. So a rectangle has congruent diagonals, right? And if they bisect each other, then you'd have some isosceles triangles, right? Everybody got that? A rectangle would have the congruent triangles in there, right? But what if they were perpendicular in this rectangle? So a rectangle will give us congruent diagonals when bisected isosceles triangles. You with me? But then let's say that rectangle has perpendicular diagonals. What does that make it? A square. Is a square a rhombus?
Yes.
high. You see how you had to work down and come back up around, see what I mean? This, you guys get this would make it a square, wouldn't it? Wouldn't that make it a square? And since square is below rhombus, is a square always a rhombus? What? Yeah, it is, right? So if we make this parallelogram a square, we've gone beyond rhombus, but we still have a rhombus. Does that make sense? Yeah.
It depends on the squares that still have. I don't know.
Yeah, because a square, remember, square has properties of both rectangle and rhombus, right? It is both of them. A square is a rectangle and a square is a rhombus, right? Everything down the flow chart is the thing above it. So even though you took a different path from parallelogram to rectangle to square, right, it still comes up to rhombus. Well, yes, they are, yes. It would have to be to make these perpendicular. Okay? All right, so we definitely have 3, so the answer is 1, 2, and 3. You see how you have to really know your way around these properties, okay? That's why I got to insist that you get these committed to memory, man, so there's not a lot of bumbling stumbling. You won't have, you won't have this flow chart on the state test. Believe it or not, they are assuming that you know all of this stuff, okay? All right, so move on to number 6. Which statement about parallelograms is always true? Always. This one should be pretty simple compared to the last one. What do you think, guys? Yeah, that's right in there under parallelogram, right? Diagonals bisect each other. Would they always be congruent? That would only be if the rectangle is parallelogram is a rectangle, a square, right? Would they always be perpendicular? That would only be if the parallelogram is a rhombus. You get the idea? And they said always. Okay, moving along. Number 7. Do make sure you make note of the shape they say it is, okay? That is critical, because that's where you go to on your flow chart, or when it's in your brain, go to that part in your brain, your flow chart in your brain, okay? So they told us it is a parallelogram, and it's got diagonals in it. When additional information is sufficient to make it a rhombus. He says 4? Why?
Because it's the definition of rhombus, it says that diagonals are perpendicular.
So AC, that's a diagonal, and BD is a diagonal, right? If we have a parallelogram and the diagonals are perpendicular, it will make it a rhombus, right? Now, here's my issue with the way they worded this question. What about 3? With the parallelogram having the diagonals congruent? Wait, not 3. Wait. What was my? Hold on. I'm going to do it. B, D, wait a minute. Wait. Parallelogram. Hold on. All right. So anyway, we get that. You just got to be familiar with the flow chart. Let's move on to number 8. If that issue reappears in my brain, I'll try to explain it. You might want to sketch this out, guys. Why would I want to sketch this out? Because they give you some segments here, right? Like, how are you going to know what part of the parallelogram these segments are, right? So make a sketch of it. So I'll do that. So we got A, B, C, D. A, B, C, and D. Okay? And are any of these choices referring to the diagonals of this parallelogram? Huh? Okay, so we might want to draw the diagonals in so we can think about it. Does that make sense? Because I don't know if you're trying to picture it in your head, keeping track of the letters and what's a diagonal, you know, like is AC a diagonal? I don't know, right? So which one would prove that it's a rhombus? Who's flowchart? What do you say? He says 3. What do you guys think? Why do you think 3? Yeah, right. Let's look at each one of them, right? Let's try. What about number 1? Angle ABC. This guy up here being congruent to angle CDA. Would that make it a rhombus? No, that's a property of a parallelogram. It doesn't change it at all, right? So this is a parallelogram. See how I write parallelogram, by the way? And that's a little abbreviation. You guys get that? Parallel symbol, then ogram. You can do that. What about AC being congruent to BD? In other words, those are the diagonals. Would congruent diagonals make it a rhombus? What would that make it? Rectangle, at least, right? And we said 3, yeah, perpendicular would definitely. Well, what about AB perpendicular to CD? That's a right angle mark. Will that make it a rhombus? Huh? Not necessarily. It'd be a what? Huh? It'd have to be a rectangle, wouldn't it? Right? But if that rectangle in turn got made into a square, then would you have a rhombus?
Yeah.
You see what I mean? Okay. All right, so the answer is 3. Number 9. Parallelogram is always a rectangle. Always. If what? Hmm? 1. The diagonals are congruent. Yep, I would agree with that. Because if you go down from parallelogram to rectangle, it's going to have congruent diagonals. What about the diagonals bisecting each other? Why not? Why would that's not? That's already. I mean, it's still parallelogram, right? You don't need to be anything special to have that just parallelogram. What about diagonals intersecting at right angles? That'd make it a rhombus, wouldn't it? But then, you know, keep in mind though, if you made it a rhombus with that and there was something else that made it a square, would you have a rectangle? Huh?
It's not always a square.
No, but that's why I said if. If that rhombus had some other information you could call it a square, would that then be a rectangle too? All right, but they didn't get that. I just want to. And how about the opposite angles being congruent?
That's parallel.
That's still parallelogram, okay? All right. Moving along, number 10. And I would definitely label these. So let's see, the perimeter 68. It's a rhombus, okay? Perimeter 68 and TG is 16. Well, what would that mean about TR and GR if TG is 16? They're 8 and 8, right? Because it's a parallelogram, they bisect each other, right? So this would be 8, and that would be 8. The fact that it's a rhombus, does it provide us any other information in this diagram? What about it? Okay. But the fact that it's a rhombus will help us do something with that perimeter value 68.1. Perhaps find something. What about a rhombus might help us do something with that perimeter of 68? What's that?
Help us find the hypotenuse of each triangle.
Okay, you took a step. Maybe not everyone follows you there. What's a perimeter made of, guys? all the sides added up. What do you know about the sides of a rhombus? Well, they're all congruent, right? So could we find the length of each side if we know the perimeter? Huh? How? So what is 68 divided by 4? 17. So we'll put a 17 down there. Okay? What else might help us here? They want us to find IE, that diagonal. Are there any other, you always ask yourself, are there any other shapes in this diagram that we know how to work with to help us? Well, okay, triangles. What kind of triangles? Why are they right triangles, guys? Because this is a rhombus. Why are these all right triangles? There you go. Right? We have a right triangle, and we have two sides of it, don't we? How do we find the missing third side? Okay, now look. If we can find that segment there, can we find the length of IE? By doing what? Doubling it, yeah? Okay, so how are we going to find that segment? What's the equation? So we said Pythagorean theorem, right? So what's the equation then? To find where I have that x. Well, let's put some specific values in that we have here. Okay, in the Pythagorean theorem, what part of the right triangle is always by itself in that theorem? Like the c squared? No. Well, what part of the triangle is that? Aha! Right? Be careful with that. It's a common mistake. This is the hypotenuse. It's always the thing by itself in the Pythagorean theorem, whether it's a variable or a number, right? So you're going to have x squared plus 8 squared equals 17 squared, right? Yes? Okay. Well, work that out and solve it. So the x squared plus 64 equals, what's 17 squared? Not 229, 289, right? Subtract 64 from both sides. What do we get? 225. What is the square root of 225? Huh? 15. Let's see. Hey, it's choice 1, isn't it? Why not? I got x equals 15. There's a 15 there. Well, on that side, all right. It's, they want IE, right? You got to be careful. So what do? IE equals 2 times 15, which is what? 30. Okay? All right? Hey, by the way, did we have to do the Pythagorean theorem here?
Yeah.
We did?
No.
Oh, why not? Or, instead of all this, are these all integers? When we got done doing it right? So is that a triple? Right? 8, 15, 17? We ran into that one, didn't we? It's 3, 4, 5, 8, 15, 17, 5, 12, 13s. And again, it's not something you have to commit to memory, but it's useful, isn't it? See how this little bit of work here, instead of doing all that, right? So 15 and then double it and get 30. All right? Well, let's move along. Parallelogram must be a rhombus. If its diagonals are, or if its diagonals, which one? I see everyone looking at their flow chart. I love it. Last marking period just sat and stared at the problem. You guys are looking where you're supposed to. I love it. Which one is it? Everybody agrees 4? Pretty simple, right? Right off the flow chart, right off the properties of rhombus. Okay, number 12. Okay, probably going to want to read that and do some labeling of things. Okay, take a minute and do that. First of all, what is the shape? Yeah, you got to know that. Okay, because then you have certain properties that will help us out. Okay, complete TST drawn. So ST congruent to SP. You better go in there and label that, right? Angle R is 130. There's a measure of angle PST. Now I'm going to put an X up here. I'll give you a moment to think about that. So you're going to have to think about not only the fact that it's a parallelogram, but about other shapes we've learned about and can apply here. Got me? You cannot forget stuff we learned before. I'll give you a minute. You guys all agree? Because of this, we have an isosceles triangle here, don't we? Well, we're dealing with angles, so what do you know about isosceles triangles or any of those angles? You gotta know something. Well, hold on. We'll get to that. That's true for parallelogram, but let's address the triangle. What? The base, it's isosceles, so the base angles are congruent, right? So can we do this? Like that? Okay. So you remember, if we can find the base angles, which are the same, it's pretty easy to find this third angle, isn't it? Okay. So now we need to know something about what shape. Because what the angle that they gave us is in which of the shapes? The parallelogram. Now you've got to think parallelogram to get the triangle. See what I mean? So think that over. Angle QP, so both pairs of opposite angles are congruent in a parallelogram. Angle R is 130, so angle QPS is also 130. Can we get to that angle there now, SPT? What is that angle pair name? Linear pair. Well, what did you say?
I said axis.
Oh, okay. So, you might have been thinking adjacent, but specifically adjacent. They're a linear pair. What do they add to? Okay. Let's see if you can work this out now. Everybody's kind of on the right path here. So, how do we find this angle right here, guys? 180 minus 130, right? Gives us what? 50. So this is 50. What's this angle? 50 degrees. We can find X, can't we? How would we find X? 180 minus 50. In other words, 180 minus 100, right? 80 degrees. Yep, just got to start getting a feel for this. You got to start keeping your mind open to all the other stuff we've learned. Okay? All right, moving along. 13. Please notice any key words in there. Like, for example, this one. And this one, right? And this one. This is where you got to put your think caps on with regard to your flow chart. Okay? Where's your flow chart at? Take that out right there. Until you memorize it, this is the only way you're going to work through this. Any thoughts on this? Yeah, what do you think? 4? He says 4. So which would not be sufficient to make the parallelogram a square. So the diagonals being perpendicular, okay? Well, the diagonals being perpendicular would make the parallelogram a what? A rhombus. And one pair of adjacent sides are perpendicular. That would mean that, what do you have in there? We got a rhombus, and the adjacent sides being perpendicular would form what? Right angles. So then it becomes a what? a square. See? You might have not paid attention to the word not. This will make it a square, so it can't be 4. Right? So this is definitely a square. Violating the not condition, okay? Not a square. What do you think? It says 3. So if we take a parallelogram and say the diagonals are perpendicular, what does that make it? That would make it a rhombus, right? Put it in here. And one pair of adjacent sides is congruent. One pair of adjacent sides is congruent. Huh, what about that? So we got perpendicular diagonals, right? That's already a rhombus. One pair of adjacent sides are congruent. So like maybe that and that. Or wait, that's not right angles. Holy smokes, what is wrong with Mr. Hopper? One pair is congruent. Like that. What does that say about the other two? Huh?
They're not.
Okay, well this thing is a parallelogram, right? What do you know about opposite sides of a parallelogram? The whole. So that and that and that and that, wouldn't that make them all 4 congruent? Well, does that really move the ball at all? We already had a rhombus, didn't we? Well, the fact that the sides are congruent make it a square? Huh? No, it'll just keep it as a rhombus, won't it? Because the rhombus already has that. Does that make sense? So it is choice 3. Let's look at the other 2, though. So we take our parallelogram and say the diagonals are congruent. What does that make it? We agree it makes a parallelogram a rectangle? Rectangle. And one pair of adjacent sides are congruent. Well, if one pair of adjacent sides look like right next to each other are congruent, we just found that all of them are, right? So we got a rhombus, right? Or we got a rectangle. That makes it a rhombus, which makes it a what? So that makes it a square. What about the first one? Parallelogram diagonals are both congruent and perpendicular. So the fact that they're congruent makes the parallelogram a what? Rectangle. And then we call them perpendicular, it becomes a what? Rhombus. It's both a rectangle and a rhombus. What is it? That makes it a square, violating the not part. Okay? I don't know, you're probably not used to thinking like this in math class, are you? Right? I'm going to make you guys some smart sons of guns out there. All right, let's move along. I want to label this diagram. And again, by probably, I mean definitely. What is the shape? Good. Got to know that, right? So point T, so PR is 16. That means these guys are 8 and 8. So this is looking a little familiar, isn't it? And QS is 30. That means these two are what? 15 and 15. Well, we have some triangles in here. What kind of triangles, guys? You understand it's right triangles because it's a rhombus and the diagonals are perpendicular, right? What do they want, by the way? So we need to add up all the sides. What about all the sides? Well, it's rhombus, right? So if we find one of them, got them all. How are we going to find that missing one? What's that? Let's look at this triangle here. Is that isosceles? Let's find that. What are we going to use? And if you don't know a triple, Pythagorean theorem, right? What's the triple? Well, the whole thing is 8, 15, 17 right triangle, right? So you remember that. He's not doing Pythagorean theorem. If you don't remember it, you got to. So what would the equation be here? if we're using the Pythagorean theorem?
Squared plus.
What now?
X squared equals.
Hypotenuse is always by itself, right? So x squared 225 plus 64, right? X squared equals, what's that, 289, right? Take the square root, right? Or, remember the triple, 8, it's an 8, 15, 17, okay? So, is that our answer, 17? They want the what? What do we do? Or, instead of adding the same thing 4 times, can we just do 4 times 17? What do we get? 68. We circle your final answer, okay? We starting to sink in a little bit, starting to see the twists and turns they take with these things. Okay, moving along. Lots of important words in here. First of all, it's a parallelogram, right? What does this say? What is it? So bisectors of an angle means we have what in there? What do bisectors do to an angle? Splits it into. So what do we have in there? Congruent angles to work with, right? Okay. So angle ABC gets bisected. So does that mean that these two are congruent? Right? And DCB gets bisected, so wouldn't that mean that these guys are congruent? You with me? And then they give us some numerical information. What's that? Nobody sees a number in this problem? 68 degrees. There we go. And they want us to find the measure of angle BEC. I'll put an X in for that angle, or a theta if you like. Okay. So we're going to have to do some thinking here about how to work our way over to that angle that they want. All right. I'm going to give you a minute to stew on it. Hang on a second. So the angle they want is part of the triangle, wouldn't you agree? What would be nice to have if we want to find this angle here in that triangle? What would be helpful to have? To find, 2 other angles in the triangle, right? Wouldn't that be very helpful? Like this one and this one? Well, you know it's a parallelogram, so that helps you a little bit, doesn't it? Check out your angle properties of parallelogram and find something that will help us here. What about opposite angles of parallelogram, everybody? Okay, how does that help us? Huh? Said I could. I don't know what angles you guys are talking about. I don't know what angle B is. I don't know what angle C is. I have no idea. You lost me. And you know why you lost me, right? Oh, now we're talking. Okay. ABE. Why don't we get to that? The one that's a parallelogram and opposite angles are congruent. There's one that's 68. What other information does that give us then? Since opposite angles of a parallelogram are congruent. That's 68. Is this not 68? Okay, that's 68. And that angle has also been what? It's been bisected, okay? So really think about that. Now you're going to need to think of a way to get after this angle here. Knowing what you know about parallelogram angles. Look in your flow chart. Look in your flow chart. Consecutive angles here are supplementary. They add to 180. So can we find the measure of this whole angle here? How do we find that? And that gives us what? 112 for this guy. Okay? But again, that 112-degree angle has also been what? If you follow me now, can we now get those two angles in the triangle? Okay, go ahead. I'll let you work on it. Did we get the measures of these angles up in here? What do you got? 56 for which angle? Oh, man, come on. What angle? So let me say it.
Angle B,
This angle?
no, angle CB.
There we go. 56. Right? You got to be specific about your language. And what's the other angle? Which angle is 34? Thank you. BCE, 34, right? Because they're bisected. They're both 34, right? And this is also 56. So now we can find x by knowing what? X equals what?
And then that's, well, that's 180 minus 9.
180 minus, to be clear, 56 minus 30. Is that a 4? Yeah.
Yeah, 34.
And we end up getting what? 90 degrees. You with me on that? Okay. A lot of thinking, and none of these, they don't ever put like super straightforward questions on this exam. So maybe at the very beginning, like, you know, first 4 or 5. You know. Okay. All right. Move on. Is there just one more? That's it. Okay. Wow, boy, we got it. Now this one, I'm going to give you some time to stew on it. Okay. You're going to need to think about parallelograms and rhombuses and parallel lines and angles and alternate interiors and linear pairs and triangle angles, adding to 180, opposite angles, parallel, congruent, every man. It's good. It's this one just takes it all in. Okay, so read it over. Well, I want to start labeling things. We got a parallelogram, right? And we have a rhombus. So we know this and this, and also this and this will be right parallel. These guys have to be like that. Okay. And we have angle B is 118. We'll put that in there. Angle AHC. Where's A? AHC is 138. And then determine the state the measure of angle GFH. GF, that's this little guy here. Put an X in there. Anybody start working their way around here? I think that. There's something down there. Yeah, what angle? Parallelogram? Okay, we'll go with that. Anybody else find any other angles in here that you can find? Yeah. What do you think there? No. Which one? Angle E? What? This is not. No. That's vertical angle with this. Not this one. Huh? This one is? Why is that 118? Oh, and by the way, I forgot this is here. Yeah, like that, right? Well, these are parallel, and these would be corresponding, right? What do you think? Yeah, so you're right. That's 118.
So
Olivia?
where 138 is,
Mm-hmm.
that whole like thing should add up to 180.
Oh, linear pair. So what'd you get for this angle?
42.
That's 42. Are we getting closer to that triangle down in there now?
Yeah.
I mean, this is right, 118. You're right about that, and you just start throwing stuff in there. I don't think it helps us quite directly. If, you know, maybe a longer path. Then what are you saying?
Or the top of the top where you see this, actually at 20 degrees, because it all of the 40.
This here? Okay, it will. But is that helping us get down here, though?
Next to the opposite angles.
Oh, you're thinking alternate interior angles here?
Yeah.
is this line parallel to some other line though? Or is this a transversal between, oh, it might be. What'd you get for this angle?
20 degrees.
20 degrees, okay, that's why I was thinking a different way. I think you might be right. See what she's doing here?
Yeah.
And maybe there's like probably 20 different ways to get at this. I didn't have that one in mind. So we got basically parallel lines and a transversal, right? See what I mean? 28 and X, or 20, that's a 20. So X will be 20, right? Well, okay, that's one way. It is 20. Does anybody get there with a different way? Let me get this mess out of here. Not the way you said it's a mess, but. Anybody do it a different way? Well, did anybody get this angle to be 42 here? Right? Okay. Does that help us? Maybe we get down in this triangle somehow? Huh?
So wouldn't G,
Why would that be 118? Well, okay, it's not 118 because B is. Why is it the same as B? Why is this angle the same as B? Huh? Yeah, so not directly related to B, right? But again, we've got parallel line, or the parallel, like if we extend that down again, same ones you were looking at with the transversal, right? 118 here, right? And then what's this angle? Vertical angles, right? Anybody take a different path? I'm telling you, there's just tons of ways to do this. Let me just move that out of there. Things not going right. Yeah. Anybody take a different path? Yeah.
You can do the measure of FHD is 138.
FHD is 1/3. That's 138. Okay. Vertical angles, and then what?
You can do
Then what?
sorry.
So that happens. It's all right. Well, maybe you can get this angle, linear pair. Is that what you're thinking? Well, then why not just use this? These two as a linear pair, right? Right? Measure of angle. I couldn't really hear you there.
If you get measure of angle, you get measure of angle after that.
Say that one more time.
So you can use 138 to get the angle or the measure of angle T. You can use that to get the measure of angle F until and then
Okay, well, let's just stipulate that 118, let's put that in there. It's such a simpler way here. What do these two add up to? 180. Let's do, or yeah. Oh, let's try it this way. What does 180 minus 118 equal? What is that? 62. You guys have to speak up. That's 62. So now can we find X? Kinda? Well, you were a very indecisive sort. You don't want to commit to anything. How would we kind of find X then, Mr. Morley? Huh?
Oh, yeah, that's right.
Right? Does that give us 20?
it gives us zero.
Oh, wait, what happened there? Did we do something wrong?
So that's not supposed to be 62, that's supposed to be 40.
Oh, somebody told me 62. Yeah. Who said 62? No. No. This is, I think he's deliberately trying to make me look like a fool, but that's okay. 42, right? This is 42. I've been made to look like a fool by much better people than you. So that's 42, right? And now we get 20, don't we? All right. Like, you don't,